Today we're taking a look at some sample problems from 7-2 that deal with estimating a population proportion. And we begin on page 377 in our text. It says in exercises 5 through 8, find the indicated critical z value. So we're to find the critical z sub alpha over 2 that corresponds to a confidence level of 80% in number 5. So if our confidence level is 80%, that means alpha is 0.20. Remember, alpha is 1 minus the confidence level expressed as a decimal. So that means in each tail we need 0.10. And this is the one you can use with our table. We'll want to use the negative table. We want to get as close as we can to 0.1000. And so we're in the body of the table. Okay, I have 0.1003 and 0.0985. The 0.1003 is closer, so that's negative 2.8. I'm sorry, negative 1.28. Something didn't sound right. Negative 1.28. Okay, so our z sub alpha over 2 would be the positive one of those. Positive 1.28. Number 6. The critical z sub alpha over 2 corresponds to a 99% confidence level. So confidence level is 99%. That means our alpha is 1 minus 0.99, which is 0.01. So each tail would have half of that, which would be 0.005. Okay, again we want to look up the negative area, 0.0050. And it's actually halfway between 0.0051 and 0.0049. So we come down, we get negative 2.575. So that means z sub alpha over 2 is 2.575. That would be the one we would use in the formula. Okay. Next one, we're to express the confidence interval using the indicated format. And we're talking about the confidence intervals are based on the proportion of red, orange, yellow, and blue M&Ms in data set 20 from Appendix B. Okay, so we have 0.165 is less than P is less than 0.335. So what we want to do first is find the midpoint of this interval. So we're going to add our two numbers and divide that sum by 2. So get a 0.5 divided by 2, which would be 0.25. And that's going to be our mean. Well, actually our p-hat, sorry about that, our p-hat. Now, we want to take the larger one minus the p-hat we just found, and that's going to give us 580. So E, that's going to be the value for E. So they want us to express it as p-hat plus or minus E. So I came up with 0.25 plus or minus 0.085. Okay, number 12 is similar to number 10. Express the confidence interval 0.270 plus or minus 0.087 in the form p hat minus e is less than p is less than p hat plus e. So what we're doing is we're actually doing the reverse here. So I want to take 270 minus 0.087. So that's 0.183. And then I want to take my 0.27 plus 0.087. And that's 0.357. Okay, so that just shows the two ways we can express the confidence intervals. All right, 14 says from a 3M privacy filters poll in which respondents were asked to identify their favorite seat when they fly. Okay, our survey consists of 806 people. 492 chose the window seat. Okay, our confidence level is 0.99 or 99%. Our p hat will be 492 over 806. 492 divided by 806. Okay, 0.610. I round it to 3 decimal places. Now we need to calculate a value for E. And that's where we use our formula. Okay, we have Z sub alpha over 2, which comes from our confidence level. And 99%, we just found it in one of the earlier problems. Z sub alpha over 2 is 2.575. So we know what that is. Q hat would be, and I know you're going to think I'm a little bit crazy here, but I like to do these with the fractions. So if I take 806 minus 492, get 314. Okay, that way I have an exact number and I don't have to worry about how many places around it get it to be accurate. So 2.575 square root of 492, notice I didn't even reduce them, times 314 over 806. That whole thing divided by 806. Okay, now what I like to do is start over at the radical. So I'm going to clear my calculator, start with the square root, and then I want parentheses around the fractions. So I'm going to put an extra parentheses around 492 divided by 806. Times another parentheses for the second fraction, 314 divided by 806. Okay, and then divided by 806, and then close off the radical. Okay, and I got an answer, and I'm going to multiply that times the 2.575. So I'm getting 0.0442 and the next number is 3. So what I want to take is my 0.610 minus 0.044 0.610 plus 0.044. I got 0.566. And 0.654. So in number 14, I'm getting an estimate that's somewhere between, and I'm noticing the book has a slightly different answer. Maybe if I kept that extra 2 in there, I don't think it's going to make that much of a difference. Maybe if I do the fraction. 492 divided by 806, then plus 0.0442, I get 0.655. So you can see the reason you may want to keep the exact figure in there whenever you can. This side's okay. Alright, so that's parts A and B. Let's see, part C, part A is the best point estimate, would be that. That's part A. Okay, margin of error. Okay, I calculated that. That's part B. And part C, the confidence interval. Okay, and then write a statement that correctly interprets the confidence interval. We can be 99% confident that the interval contains the population proportion P. Because 99 out of 100 intervals that we would construct in this manner with a sample size of 806 will contain the population proportion P. Okay, let's go on to number 18. Says the Genetics and IVF Institute conducted a clinical trial of the Y-sort method designed to increase the probability of conceiving a baby boy. As of this writing, 291 babies were born to parents using the Y-sort method, and 239 of them were boys. So our N is 291. Our X, the number of boys, is 239. Best point estimate would be 239 over 291. So 0.8182.